Find the charge on the capacitor in an RLC series circuit where L equals 1/5 henries, R equals 2/5 ohms, C equals 1/2 farads, and E of t equals 50 volts. Assume the initial charge on the capacitor is 0 coulombs and the initial current is 4 amps. Okay, now there's a lot going on here, but let's start out with just the known equation, and that is L times the second derivative of Q plus R times the first derivative of Q plus 1 divided by C, end fraction, times Q equals E of t. Let's take all the values we know, replace them in here, and see if we can reduce this to an more easily solved problem. So this is equal to 1/5 times Q, or the second derivative of Q, plus 2/5 times the first derivative of Q, plus 2/5, 1 over C, C is 1/2, plus 2Q equals 50. Now, I'm going to multiply every value here by 5 to eliminate fractions, so that this will be the second derivative of Q plus 2 times the first derivative of Q plus 10Q equals 250. Now let's consider the complementary equation and the characteristic equation of that. So that would be lambda squared plus 2 lambda plus 10 equals 0. And solving that, we can find that lambda is equal to -1 plus or minus 3i. Which means that our general solution is of the form e to the -t, end exponent, open parentheses, c sub 1 times cosine, open parentheses, 3t, close parentheses, plus c sub 2 times sine, open parentheses, 3t, close parentheses, close parentheses. That's our general solution. And based on the r of t that we have, 250 in this case, based on that, we're going to make a preliminary guess that Q sub P T is equal to A. That's because 250 is a constant, so we're going to suppose that our particular solution there is a constant. Okay. Now, if we substitute that value, that function A, into our equation, the second derivative of A is of Q sub P is 0. The first derivative of that is also 0, so this gives us the equation 10 times A equals 250, so that A, our coefficient there, is 25, or our function there, is Q sub P of T equals 25. Now, summing these things together, we can have our general solution of Q, our particular solution. It's the sum of our general solution and our guessed function that we have with our parameter. So Q of T equals e to the -t, end exponent, open parentheses, c1 times cosine, open parentheses, 3t, close parentheses, plus c sub 2 times sine, open parentheses, 3t, close parentheses, plus 25. Now we know our initial charge, that is a value of Q, so Q of 0 equals 0, and the initial current, that is Q prime at 0, that is equal to 4. Now finding the derivative, It's probably the hardest part here, just because it's a new product rule. So we find our first derivative, and we take our original function, evaluate them both at 0, and we come up with a system. C sub 1 plus 25 equals 0, and negative C sub 1 plus 3 times C sub 2 equals 4. Combine these together, and we see that the C1 is negative 25, and C2 has a value of negative 7. So that our final solution here for charge is Q of t equals e to the negative t, end exponent, open parentheses, negative 25 times cosine, open parentheses, 3t, close parentheses, minus 7 times sine, open parentheses, 3t, close parentheses, plus 25. That is our equation for charge.